valve. It was advanced for their time, 1-inch valve, but that's the very first valve really for in-floor cooling systems for the campaign. And then of course we've got the 1.5 inches, and then next we have the 2-inch. The 2-inch valve is our low pro valve. It's the most popular valve. It's the valve that their new pool builder is going to send us a plan, and we're going to lay everything out. I'm going to recommend the 2-inch valve. The 1.5 valve there comes in a 5 and a 6 port, and we have a 5 port that has push-in flaps that lines right up with some competitor valves like Caretaker. So it lines right up, so you can literally cut one valve out and put that one in. We have some templates which we'll also discuss. It'll make it easier for you when you're replacing stuff down the road also. And then finally, before, what they used to do was they used the plumbers, right? So this is a very plumbing-centric product, and so the way it was done is they laid them out themselves. So the plumber would go out there with a tape measure, and they'd kind of ballpark approximately how far that turbo head would clean, and they would lay all the pipes out all themselves. Fast forward to computers and CAD and being able to actually do stuff scientifically a little bit more. That's where we're at right now. So the way it works now is if you're building swimming pools and you want to use our system, you basically send in a cover sheet which has hydraulic information and whatnot. You send in a pool plan, preferably one that has length and width dimensions, maybe not on a napkin, and send that in, and within a few days we'll send you a pool plan back. It'll tell you where all the heads need to go. It'll be spaced out for the plumbers to be able to install everything, for the guy to set the heads, put the heads in the collars, start everything up, and everything works like it's supposed to. So that was before, this is now, and this is an example of what one of the layouts would look like that you would get back.
So with in-floor systems, they're more hydraulically sensitive than like a suction cleaners, other types of cleaners. So sometimes they can feel a little bit complicated, like, yeah, I got this thing, it's not cleaning well, what do I do? And the reality is all in-floor problems can be broken down into one of two things. It's either a flow issue, like a flow or pressure issue, or it's a physical issue with inside the water valve, normally like with the gear kit, like with this, or with the cleaning head. So it's only going to be one of those two things, either a flow issue or a physical issue with one of those two things. Some things that we need for in-floor systems to work well is flow. When we have dirty filters like the ones on the left, and we see this all the time where, hey, my in-floor is horrible, it's not cleaning right, I don't know what's going on, and we go out there, we pull apart the filter, and we see that. So what problems might that cause? Yeah, it kills your flow, right? We have almost no flow coming out of it. So we clean the filters, and all of a sudden we get the flow we need. Also, you need good plumbing. We'll show some pictures of bad plumbing. Hopefully it's none of yours. That we're going to show in a little bit. But this is like a pretty clean plumbing. You've got a nice little suite. One thing that I don't like on here is it has a suite 90 right here, which is more restrictive than a suite or even like a regular 90. So this is just an example of like the way that we would want something to plumb. We want it plumbed fairly clean, in line as much as possible. The fewer 90s we have, the better. So does anybody know with a 90 about how much restriction, how many feet of pipe is that? Like a 2-inch 90?
8.6.
Yeah. And you'll hear it different from different manufacturers stuff, but 8.6 is a good number. And so if you think about it, if we have pools where it comes out of the filter, so we're on the pressure side now, and we have 990s or 1090s before it gets to the water valve. That's the equivalent of pushing that pool out like 80 to 90 feet away from, or the equipment 80 to 90 feet away from the pool. So it just, the farther it is away, the harder it is on the hydraulics. It's not going to work as efficiently. So we want to clean those up if we have those situations where they're not plumbed well. We want to clean those up, and it makes a big difference. We've seen systems where they're plumbed pretty poorly, and just by cleaning up the system, all of a sudden, if the pool wasn't cleaning, we couldn't even get the correct pressure we needed at our head. Does anybody know what the correct pressure, besides the front row here? Does anybody know the correct pressure that you need at the cleaning heads?
12 PSI.
What's that?
12 PSI.
12 PSI, you could do 12, yeah. 10 PSI is what we're looking for, 12 is a fine number too. But 10 PSI is what we're looking for. So we've had systems where we go out there and we're getting 5 or 6 pounds of pressure, the pump's running at full speed, and we have them replumb the equipment area, clean it up, put sweeps instead of 90s, or sometimes we'll see a 90 going here, into the valve, like crazy stuff, just because somebody had to fix something at one point. And I've done similar type of stuff because it's easier to maneuver sometimes when you're in those tight spaces. But the more that we have of those, the more restrictive. And we've had it to where we're getting not nearly enough pressure. We clean up the plumbing, and all of a sudden we're getting 11, 12 pounds of pressure up the cleaning tanks. So it makes a big difference on stuff. So cleaning heads. So some of the things that we see with cleaning heads, we go out there and the heads aren't fully extended. They're just kind of floating up a little bit like this. So when it comes on one zone, say it's floating up like this, it's not coming up all the way. What do you think might cause that? Pressure, flow. Yeah.
The stuff on the screen?
Debris in heads, wrong orifice, maybe too many heads in the zone.
No, that's good. Yeah. So flow is probably the biggest thing. There could be debris stuck in the head, stuff like that, but it could be flow. We could have the wrong orifice. Like one of the things we're going to be talking about is zone balance. What that means is each group of heads that come up, we want them to be equal gallons per minute per zone. So when these 4 heads over here pop up and these 4 or 5 heads over here pop up, we want the gallons per minute to be equal or fairly close to being equal. What that does is it gives us equal pressure throughout all those zones. If we have one zone that has, say, the second to the largest or something like that on there, and then we have the next one that has the very largest on all of them, we're not going to get the same pressure on both of those zones. It's kind of like if you have a sprinkler system, if you have 4 sprinkler heads that pop up on one area, and then you have 20 on the next one. What's going to happen to the one on 20?
It's gonna not live.
Yeah, they're going to, right? It's going to do hardly anything for you because we have too much of a demand there, so it doesn't work right. So that's the same thing with having too many heads on a zone. We don't generally design that way unless there's some kind of a mistake. But some manufacturers will do 6, 7, we've seen 9 heads on a zone. And that creates some issues to try to get the correct pressure we need.
So in that scenario, if it's already built, what do you just lower the orifice to get the pressure back?
That's one of the things you could do, yeah. If you say if there's too many heads on a zone?
Yes.
Yes, that's it. If it's a caretaker, you can also use the wrong caretaker. So, but you can put a little bit of tape around where it locks into place. Have you done that? Okay.
Yeah.
Like a little bit of electrical tape.
So the caretaker head's designed to have a 2 GPM bypass around it, so what he's referring to is like a makeshift O-ring. So sometimes they'll
And it
take
doesn't have
electrical
to-
tape and go around it. So the other thing you can do is obviously clean up as much of the equipment area as you can, we discussed. And then replace the valve, if you got into that. The reason you would replace the valve is the valve also has a little bit more bypass. It's just older technology. Came out in the 80s. So this valve, the 1.5-inch valve, came out a while ago, but it's been re-engineered because it actually has push-in flaps. It's just a much better design.
So when you're saying replace the valve, if I have 1.5 inches, get the new 1.5 inch, it's gonna be better?
Yeah.
It seals the other ports better.
Yeah, if you have a 5-port caretaker, our 5-port valve has the exact same footprint, and you pick up 15 gallons a minute more per zone. So we've had some pools where they're just kind of barely cleaning, switching out the valve, and then it makes a big difference. So it kind of helps overcome some of that bypass.
That's the template.
So if we're getting low flow or low pressure to our cleaning heads, here's some common things. The biggest thing that we see is a dirty filter. We hear that all the time where it's we'll ask them, when's the last time you cleaned your filter? We just did it a week ago. And they're getting the skimmer basket confused with the filter or something, because we go out there and there's mud caked in there or something. So the filter will cause that low pressure or that low flow. Also, we want to make sure that all the water flow is going to the water valve itself. If there's a return line that's open, sometimes people go like, hey, we're going to crack that open a little bit. You can, but it's not best. It's not designed that way. It's designed to have no water flow to the return line because we need all that water flow to go to the water valve. With that return line open, sometimes it'll be open up completely. When that happens, the water always takes the path of least resistance, so it's going to go to that first before it goes to the inflow. It just kills the pressure. So again, if we were checking pressure at the cleaning heads, which we have a tool to do that, we'll talk about it in a little bit. So if we were checking pressure at the cleaning heads, and say if we had 3 or 4 pounds with the return lines open, we might not even have that much. We can close that, we'll jump up to like 14 or 15 pounds of pressure at the cleaning heads, which means we have to drop speed down a little bit. We could have a bypass that is either closed or missing. So we normally want a bypass on heaters, salt cells, things like that. And the reason for that is because they're restricted. Every little piece of equipment that we have like that is kind of like putting a kink in the hose. So as the water's flowing through there, we slow it down a little bit on each thing. So having a heater bypass, that just allows most of the water to go in the heater with a little bit of bypass around it. So we could have the pump speed or the size is wrong. So sometimes that just happens. At low speed, when the cleaning head system is on low speed with an import, the heads are not designed to come up all the way and work right because they're not working because we don't have enough flow. Excessive fittings, we talked about that before with a bunch of 90s and different things like that. Also, the water valve can be worn. And we see this a lot with the old ball valves, inch ball valves that we have, because those balls would rock back and forth in the port as that cam moves them around, and it ovalizes the ports. And so as the ports get ovalized, we can bypass in there. So we want to make sure that if you have a really old water valve, that it probably needs to be replaced. Also, the T-flaps may need to be replaced too, because these can get worn and cause bypasses. So if we have dead areas around, like on one zone, if it's just one zone itself, not in the entire pool, but just one zone or around one cleaning head, common problems are debris in the lines. We see that a decent amount, especially on new construction or after a remodel, we'll see stuff stuck in the lines. Like this one right here, around that head, I guarantee they're gonna have all kinds of dirt around that specific head. So if you see it around just one head, it's either the head is damaged and it's not functioning right, or it has something stuck in it. If it's around just one head, if it's on just a zone, it could be that like a flow issue. It could be an issue with the water valve itself.
Besides debris and stuff getting in the line, what can happen with the cleaning system is when they're installing the heads, before they do that, they're doing aggregate or using pebble finish or anything like that. There's a slurry that can actually get in the pipes. And our heads are designed, we actually have like a sponge in there, and that's typically how the exterior finish guys will do it. They'll put the sponges and stuff in there to stop some of that slurry from getting in there, but it still gets in there. So what can happen is, first of all, when they start to pool up, a lot of times they'll take the heads out and they'll clean everything out. They might do that for a couple of days, a week, or whatever. But unfortunately, you really need a significant amount of pressure to push all that stuff out. So if you have a situation like we're into where you have debris in there, or you notice that the head's kind of like floating, or basically there's a dead area, take the head out completely and let it cycle around. And again, water travels the path of least resistance, so water's only going to go to that one pipe, and it's going to push all that stuff out. So now we have all that heavy pressure instead of all the heads out on that one zone. So now we're going to be able to get all that stuff out. And the crazy thing is, I was on a job yesterday, pool started up in January. We still had a significant amount of slurry coming out of the line. And they did everything I just said. And the reason is the pH fluctuation, that slurry has basically got like aggregate. They use an acid wash to clean it up. And over time, with the fluctuation of the pH and the water chemistry, that slurry is probably on the inside of the pipe and it just starts to flake off. So after, from January to October, in this case, stuff came out, take the head out, clean it all out, God bless you. And everything's working great. Put it all back together and away we go. So, and one thing we're going to talk about too is, and that's why we pass those heads out. Another reason is we're going to show you how to take the heads apart. I'm sure a lot of you guys know the Venturi head's a little bit different, so I wanted to go over that because it's just a good maintenance when you're in your backyard to check the heads and stuff. A lot of times, and again, it's not like it damages the head. It's just there's some stuff in there. Once in a while, it might damage, but for the most part, it's just debris and stuff that's in the way. So if we get all that out of there, then the cleaning system will do obviously a better job.
Yeah, and so one of the things too that would cause an issue on just one zone is we have the wrong orifice in here. If you have too small of an orifice, it's going to cause a problem. Also, if you go to a pool and you see the indoor system, the whole entire pool is dirty, and on one zone, you see like a little clean streak on that zone. Any idea what might be causing that?
We call that the cone of shame.
The cone shape? Yeah. So if you just see one little clean spot, the whole rest of the pool is dirty, but on that one, you just see that cone. What that means is that the water valve is stalling on that zone. One of the things that can cause that is, again, wrong orifice openings, because the water is flowing through the water valve, it hits this little propeller here, and it spins it, and when that's spinning it, that spins this gear kit around, that comes around and it lifts up the different flaps. And so what's happening, it's flowing, say if it's flowing at, remember, 70 gallons a minute for each zone, and then all of a sudden it goes to one zone, and somebody changed out the heads from what it should be to the very smallest ones on there. And we went from 70 gallons a minute to 24 gallons a minute. What happens is that it creates a ton of back pressure. So as the water's trying to flow through there, it's flowing 70 gallons a minute. It's the next one where they're not done correctly, and it's hitting 24 gallons a minute. And it's going to cause the water valve to stall, or it's going to cause it to wear out really quickly. Just a fun story. Shortly after I started, we had a customer that called into our office just saying, hey, I've had to replace my gear kit on my pool. She had a low profile gear kit. I had to replace it 3 times in like a month or a month and a half. She goes, I just heard you guys are having problems with your gear kits. I'm like, you know, we might be, but that seems a little bit crazy. So I went out there to look at her pool. She had an older system where she only had 2 heads on each zone. And on those, what they should be is when there's only 2, there should be the very largest opening, which is a 9/16. So we're looking at about 60 to 70 gallons a minute for those 2 zones. So 2 zones, they were all good. And then I noticed when it got to where there was just 1 head, the pressure on the filter just jumped up and spiked. When it was just on one, somebody had, instead of putting it in the very largest and maybe double poured it by drilling out some holes, they put it in the very, very smallest one in there. So you went from like 60 to 70 gallons a minute to 6 gallons a minute. And so it just created a huge amount of pressure inside the gear kit. So it's just fighting itself, trying to do something, and it just causes it to wear out. So we fixed that, and she never had an issue after. Yeah.
Did you say drill through the whole entire thing, through the orifice? So
Yeah.
open it up the back
So,
too?
and that's more like a retro kind of thing, like on an old system where you only have 1 head. We have heads, like our old style 1 heads that we showed, to where we have the big hole here, but then they also drill holes on the side for that situation.
Just so you really pressure
Just
gets
so you
coming
relieve
in.
the pressure, we're trying to get that equal gallons per minute, yes.
Yeah, a lot of times I've talked to people where they think the smallest off nozzle, it's almost like a garden hose, is going to shoot the farthest, right? So more than likely in that situation, someone taking care of the pool or whatever was thinking that. There's only 1 head, maybe there wasn't a lot of area, so they probably put that smaller one on. Obviously, that is the exact opposite of what we want. So remember, the larger nozzle uses more water, but it's going to shoot farther. So when we design our pools, in this case, we use our Venturi heads, but it basically cleans a bigger area, as opposed to, in this case, say the 6 gallon one is going to be more for depth suspension. So, as many times as I've done this, I've had more than one conversation with somebody over the years, where they're like, it's a smaller one, it's going to clean it. Doesn't work out.
Because they think of it as a squirt gun, but it doesn't have the mass of the water that it's trying to overcome. So that's why we need the larger volume of water to get those cooling. So if there's multiple areas, like the whole pool is not cleaning, it's going to be a low flow or pressure issue, or it's going to be that the water valve installed in one place or installed in between zones. Any questions on that part? If you see the heads floating, like all the heads floating in the pool like this, whenever we sell these water valves, because they're designed for new construction, and we want all of these ports to be open, because what happens is on a new construction is they're going to have all these plumbing lines going out there, and we have to pressurize those lines to make sure that there's no leaks. It's something that's it's a requirement by the different cities. So there's a little pressurizing ring that lifts up all of these flaps. So if you have a new pool that you go out to, that has to be removed. If that hasn't been removed, the water is going to all the different zones at once, and so it'll never clean right, and you'll see them all floating up. So that's probably one of the biggest things that was. Also, worn and damaged ports. Again, if we have worn ports like on the wall valve, where this is worn, the water is always flowing around all of these, even though we're trying to get it to flow to one of them, but it's really flowing to all of them because there's always a little bit of bypass. You'll see HUDs floating out. Also, on some aftermarket manufacturers, the springs aren't right, or just things aren't designed quite right, and you'll see them floating up like this on some aftermarket stuff because it's not designed for the system. All right, that's going to take you to the water valve.
obviously, water valve is important, kind of like the brain of the system, so we need to make sure that's functioning properly. So a couple things down to the warm gear kit. So I'm going to do this real quick so you can see what you don't want to see. So obviously that propeller is pretty worn down, so that gear kit's pretty, it's definitely needs to be replaced.
What should it look like?
Here's what it looks like. So someone kind of went to town on their gear kit. So more than likely just one of those things that someone had taken it apart. They probably saw something spinning because it is clear on the top. And just assumed everything was fine. So obviously that's going to cause an issue because the zones aren't going to be rotating, so therefore the heads aren't going to be doing what they need to be doing. We've got a situation where there's back pressure from restriction. So in this case, it could be back pressure from the heads being clogged, and causing back pressure on the valve, but it can also be back pressure down the line, and causing the valve to stall. Pause control's on. That's a pretty simple one, guys. Everybody's familiar with the 6-port valve. It's got a pause on here. The reason this is on here, obviously, is to stop it on one particular zone. It is a nice feature. We're going to talk a little bit about testing the pressure at the heads, because you can stop it on one line, and you can check the pressure at the head in particular when you're doing some troubleshooting. Low flow to the valve, that's pretty obvious. So if it's on a low speed, so if it's on basically a verbal speed pump, if you've got a low and a high speed, your propeller is going to be spinning fairly slow. It's still going to be rotating, so this is designed, it doesn't need a ton of water for that propeller to spin. However, it's not going to be doing cleaning, it's going to be more about circulation, chemical distribution, and then debris in the gears. So if there's any debris and stuff in the gears. These are typically installed after the filter. You can install it without a filter if you have a situation where, let's say you have a larger pool, you got one on a filter and one not on a filter, you just have to keep that in mind. Obviously, if it doesn't have a filter, you could get some debris in there. So, any particular questions on that at all? Or? No? Your kid's wearing quickly. So, chlorine feeder. So, definitely we've seen it where if you've got a tap feeder, erosion feeder of any kind, that low pH, what's going to happen is it's going to wear down all of the stainless steel stuff in here. This bar right here will start to almost like oxidize. The actual flaps can have an issue as well. So we want to keep that in mind, just like with anything. Even with the heater having a check valve, we want to protect our equipment, i.e. the valve. So if you have it where you have a chlorine feeder on there, install a check valve, so when it's off, it won't travel back, because that's really where it gets it the most. But more importantly, maybe try and move it where it's not as close to the valve, because that will wear it more. High speed, so running this thing too fast, just like anything, if you run something too fast, it's going to wear down more, so pretty obvious there. So we want to keep that in mind. And again, what's really nice about the valve, sensory heads and all that, we don't have to run it at 3450 or 85 gallons a minute. We can bring that speed down significantly. We can drop the filter pressure down, so the cleaning system will do a much better job. And I probably wouldn't have been able to say that like 20 years ago. So technology's improved, because of all of the technology, the wearable speed, being able to run something lower. Now we can take advantage. We have a system that works well with wearable. 6 months. And then obviously improper zone balancing. So again, like Greg was referring to about the two heads and the one head, you want to make sure everything's balanced, because if one zone is 72, the other one's 24, we're having some issues with zone balancing, we're going to wear that valve down. And besides wearing down the valve will literally stop. So I've had situations where people will call me and they'll say, hey, the valve isn't moving. So they just assume valve's not moving, propeller's not moving, there's something wrong with the valve. But what it is what's affecting the valve, which is too much back pressure. So always keep that in mind. The easiest way to troubleshoot it too is that besides having basically a rock or something in there, if there's a particular line that it's stopping on, just take one of the heads out of one of the zones, and then basically that opens it up, so it gets rid of that back pressure because all the water's now going into that line, and so that valve will start to cruise along here. Yeah, so first of all, T-valves need so inefficient function, I like to focus on that. So the reason I want to show this slide, because it's train wreck, is this is stuff that can be fixed, right? So when we talk about a uniform cleaning system, this is the brain, we have the heads and all that, but it needs good flow, it needs pressure, in order to make those heads pop up. So if I can clean this up, solid heater bypass,
Needs some paint. Needs paint.
get rid of a lot of that stuff. It makes a world of a difference. The cleaning system will do a much better job. Like I said before, you know, this cleaning this stuff up, you can see it personally. It makes a world of a difference. The system will do a better job. Every vacuum heater that uses up a lot of water too, so you know, cut that out, put in heater bypass. There's tons of stuff. But keep that in mind besides just replacing the equipment, you know, focus on the plumbing. And then T-valves need to be replaced. You already mentioned that, but that just obviously, T-valve wear down. What can happen is I lose water. So now instead of one zone being on and getting all the pressure, all the flow that I need, it actually is getting water to all the other lines. So two things will happen. One is you might see some floating heads, but also the actual valve needs to be replaced, the T-flaps or whatever, because I'm losing that water with the bypass.
Question, is that set
Yes.
up on two separate systems, or is there supposed to be a two-way to push those? How's it go back and forth?
So that guy right there, I think there's 3 valves on it, if I'm not mistaken.
More than likely, it's the Shasta that has a valve actuator between the two.
Yeah, that's it, Mike. So, yes, that probably has an actuator.
Hey, you can see it on the bottom right. Yeah.
That's suction. That's the
Yeah, that's suction side. Oh, that's because of the leaf vac.
What?
That's the suction side. The leaf vac.
Then leaf vac on the return side.
Maybe that one there.
It could just be 2 pumps.
Yeah, I don't think that's an old pool. Anyway.
That's the old JVA, yeah.
Yeah. Okay, sample plumbing. So speaking of So, we wanted to show this to the folks doing service and repair. These obviously, you know, this is a pretty simple job right here in the middle. The one on the left, that's got Mr. Satan 3 valve on there. It says 3 valves. So this is a dual valve. So this actually has a 2-port valve feeding 2 6s. So Mike was referring to the actuator previously on that pool that was probably Shasta in this case. This is a 2-port valve, and then eventually it rotates and goes to the 6 and comes back around to the 5 and so on. But you can see, I mean, good plumbing, it's got obviously the valves and everything, but one important thing is knowing where everything is. What would help to identify where everything is?
Labeling.
Label it?
Pictures.
Plumbing label.
You guys put these on and off?
Every pool.
Yeah, plumbing labels. You go in the backyard, and so obviously we have these as, you know, for layouts and everything, show you the pool, drain, suction, all that. So please be sure to put these on. Does everybody buy these? Buy these.
I buy them.
A lot.
I'll ask you another question.
Ask YouTube if anybody buys them.
What did you say?
Nothing.
Cool. All right. So heavy debris. So this is an important one. So before we had basically drains that could capture larger debris and whatnot. We had separate drains before BGB. Well, before BGB we had single drains. Then we got into dual drains. So this is our. This is our unblockable drain. This is our channel drain. It comes in a single and a dual inlet, but it will capture your larger debris and stuff like that. So if you have an indoor cleaning system and the issue is heavy debris, the question is what kind of drain do we have? So you can see the picture there. That's a double top, like this one is here, so it matches nicely. So the newer pools, probably the past, I don't know, 7, 8 years or more, our dealers install this drain on there, so it goes in conjunction with the cleaning system. So besides the valve and the heads, this comes with it also. What's nice about it, again, is it captures the larger debris. The other guys out there, so Paramount has an MDX drain, it has a side suction, instead of having it basically, you know, where it's all one piece. And the reason they have to have that is for BGB compliance. You guys had Mike's class previous, he was talking about the air entrapment thing and all need to be clean, that's pretty obvious, right? And we're trying to get that flow, we're trying to get that suction, so that pump needs what it needs in order to move the valve. And the filter needs to be clean, so that's pretty basic. One other thing that's nice about having a suction drain like this is the way our system is designed is you can use what's called a Venturi skimmer. I don't know if you guys are familiar with this, hopefully you are. So our system's customers will install our Venturi skimmer, which basically only needs 6 gallons a minute. So instead of the traditional standard suction side skimmer, so this only needs 6 gallons a minute, but it actually pulls 60. So what happens is that rear door pulls down to the Venturi action. And because we only need that, we can put the majority of our suction here. So this actually does a much better job than a traditional drain. So if you have a system of ours that's out there, you guys are taking care of the pool, and it's got one of these and a Venturi skimmer. One thing you want to do with the Venturi skimmer is on the actual plumbing line, inch and a half or 1 inch line, make sure that valve isn't open all the way or closed. Crack it a tiny bit, because it only needs 6 gallons a minute. And if we have that open all the way, we're going to lose more water. We're not going to get it to the input. It's not necessary. And then on the suction side, in front of the pump, we're going to put it more towards the drain.
You guys, what happens when you have a standard drain, like a normal, non-heavy degree removal drain with an in-floor system? What happens? It's clogged. What? Right? Yeah, because you guys, when I did my pool, luckily I put an A&A system. I didn't know anything about A&A at the time, but I put it in probably 20 years ago. And when they plumbed it, they just put regular standard type of drains. And so my neighbors to my side have bougainvilleas, and neighbors behind me have bougainvilleas. And like when those things shed like that, I literally have like 2 little chia pets down there. So because they have no place to go. The leaves, once they sink to the bottom, without a heavy removable drain, you're in trouble. So it's really, really tough to clean those up. So if you are doing a remodel or something on a pool that does have those, be sure to put a heavy removable drain on it. It'll make a world of difference for you. So zone balancing. So if you guys could open that QR code thing that we did, if you guys can pull over that file, and then there's one that is called systematic in-floor troubleshooting. Actually, there's a couple things. And if you guys could go to the second page of that, is where we're going to go to the zone balance. So one of the first things that we have to determine, and it should be the page where you see like the cleaning heads going across there. Do you guys see that? Okay. So the first thing we have to determine is what kind of head is it? Is it a style 1, style 2, or is it a G4 head? G4, G4B. So these first 3 ones, the first 3 you see in the picture there, those are all going to be either quarter-inch. When they were designed, they're either quarter-inch, which is the very smallest opening, or they're the second to the largest opening. And the gallons per minute on that, it's either 6 gallons a minute for the small one, or 18 for the large one. Okay?
I was gonna
We
answer.
know the flow rate for a G4V head. Kyle, do you know that? Yeah, 12, exactly. Yeah, so the Venturi
Oh, I said that
heads
earlier.
are 12 gallons a minute. So whenever, what we're doing is when we're coming out to a pool and we want to figure out what's going on, we want to make sure that, remember when the heads come up over here and the heads come up over here, we want to make sure that we have equal gallons per minute or close on all of those zones. And the way we do it is we come out and we look at the pool and we see how many heads are popping up just on the floor of the pool. And the reason why it's just on the floor of the pool is if it's an A&A system, is because we always design with only one type of head on the floor of the pool. They will all have the same gallons per minute per head. So they will all either be at 18 gallons a minute, or if it's a Venturi head, the ones with the salt and pepper taper that you're looking at, if it's one of those, then it's 12 gallons a minute. So that's what we're looking for. So, question for you. Oh yeah, real quick. The small top step will always be the smallest opening on a non-Venturi head. And the reason for this is it's just covering a small area, doesn't need to clean a very large area. We also don't want water shooting up on top of the deck. That's what will happen if it has too large of an orifice or if the Venturi head goes in. Yeah, if you guys take this side out, the one that's the solid top, if you guys pop that open, and then the top, you can just twist open the top, and that's how you adjust that. And so the very smallest one is a 1/4 inch, that's 6 gallons a minute. The next size up is 12 gallons a minute. The next one up is 18 gallons a minute. We only designed with those 3 openings. You will never need to use the very largest one unless you have some trouble area that's not clean. So we just save that as kind of like a fix. So when you guys go into distribution, and you ask for a clean A and a clean head, what do they ask you?
Floor steps.
Yeah, color, floor step is a really common thing. So the assumption with that is that all the heads on the floor are one size, and all the ones on the steps are another size, but that's not correct. Okay, so by doing that, you'll end up getting zones that are really, really out of balance. The ones on the floor are always the same size. They're always 18 gallons a minute on the non-Venturi heads, and it's always 12 gallons a minute on the Venturi heads on the floor. The steps and benches can have a mix of both of those because we want to make sure that they're balanced. So if you look at that chart, the very smallest opening is 6 gallons a minute. That's what they would call a step, right? A step or bench. So if we had 4 heads that came up that were 18 gallons a minute on the floor, what is our total gallons per minute for that zone? 72, okay? And if we had 4 heads that popped up on the steps of the pool, and we put the very smallest in there, and they're 6 gallons a minute, what is that gonna be?
24.
Yeah, so we're gonna go from 72 gallons a minute to 24. And so that's a really, really big disparity between those. So what's gonna happen? It's gonna cause air to wear out quickly. It's probably gonna cause the valve to stall also, because those zones aren't balanced. So what would we need to do to those 4 heads? Remember, the 4 on the floor were 18 gallons a minute each. What would we need to do to those 4? Say if they were in a bench, they were all in benches. What would we need to do to those 4 to make it equal?
Shrink.
How old I can't hear you?
That's true.
Yeah, open them up. Yeah. So we want to change from that very smallest opening to the second to the largest, and that's our 18 gallons a minute. Another little trick too, if you look at the smallest one, if you look at the very smallest one, the one opposite of that is the one that's the large one that we designed with. And it takes 3 of the small ones to equal 1 of the large ones as far as gallons per minute. So we just want to balance those out. Anybody have any questions on that? It's a little bit confusing. This is kind of an example of pool. So this is a pool, the V's just mean Venturi. So those are 12 gallons a minute. So what would our normal floor, like what would this floor zone right here be? How many gallons per minute? 48, yeah. And then so in order to get this here, now we're dealing with steps and then this top step here. So we have these as Venturis, they're 12 gallons, so we're at 36 gallons a minute. And then if we drop these to the smallest one, the yellow overflow, that's the very smallest, that's 6 gallons a minute. So we have 36 plus 12 is what? 48, yeah. And also another way to look at it is 2 of those low flows, the ones that we can adjust, the very smallest, 2 of those equals 1 of these. So the zone balancing thing is a big deal because when we get things out of balance, the pool's not gonna clean right, it's gonna stall, it's gonna cause all kinds of issues.
So the Venturis are using 12 gallons off the turnpike. What is the output? Because I know they're drawing in on, so what's the estimated output?
As far as the distance?
Yeah.
The distance. So they clean, that's actually a really good question, I should have covered that. So one of the things, if this was a standard, and it was 18 gallons a minute, like a standard, the one with the solid top, 18 gallons a minute, the turbines clean the same area. So they're more efficient, we have less bypass on them, they clean the same area a little bit wider actually, but they clean exactly the same area. So one of the things that's nice is with the variable speed pump, if you have a pool that has the solid heads in there, and they do have a variable speed pump, you can take these out, and you can put Venturi heads where these large openings want to. And then so you drop down by 1/3 of the water flow, and so 1/3 of the less water flow equals about how much in savings? What do you think?
Half.
Yeah, it's about half. Yeah, it's about half the savings. So we've seen pools where we taking out the old standard top ones, and then say we were getting 10 psi, whatever the pressure gauge, we'll talk about in a second. Yeah, okay. So what it is we have a pressure gauge, and we sell this, we use this for troubleshooting all the time. So what we'll do is we'll take out the mold head, and we'll put in this gauge, and it has like a dummy head with the long hose with the pressure gauge. And then we're looking for about 10 pounds of pressure at the cleaning heads for them to function properly. And that's kind of for all manufacturers. So Banner will show you there.
So basically adding like 6 gallons of flow.
I'm sorry?
So basically adding like an additional 6 gallons.
It's drawing the water in through the vented cap, so we get some additional flow there, but just because we're getting less bypass, it's just a more efficient head. So what that does though, is by replacing it with, let's say, like we might have this system, we put the pressure gauge in there, we're getting 10 pounds of pressure at, say, 3,200 RPM. We take these out, and we put the Venturi heads in, and all of a sudden our pressure jumps up from like 10 pounds to like 16 or 17 pounds of pressure. So it forces us, that's why we need a variable speed pump, forces us to drop that pump speed down, which saves the customer money, and it cleans better. So we get good cleans and get less energy.
So, on a new pool, existing pool, everything's set up around